Hello, this is the first in a series of videos that I will do on exchange economies. I will talk about what it is, that is how we can define the model. I will show you how to solve it, and I will explain how to interpret the mathematics in terms of our economic interpretation. We have two players that I call A and B, and we have two goods, 1 and 2. To define the model, we need six equations. The first two are the utility functions, and they tell you the utility that each player obtains from his share of the consumption. Then we have the physical constraints. There's a maximum amount of each good. In this case, I've set them to 8 and 6 units. So the physical constraints tells you that the total amount of consumption, which is on the left-hand side, is equal to the supply, what is available. And then we have the monetary constraints, and these tell you that the total budget for each player on the left-hand side must be equal to the expenditure. So on the left-hand side of the monetary constraint, we have the budget, the prices times the initial allocation. So for example, player A starts with 2 units of good 1 and 4 units of good 2. So his budget is P1 times 2 plus P2 times 4. This is the Edgeworth box for this model. Down on the left side, you have the origin of player A, and up on the right, you have the origin of player B. And you can see that on each side of the box, we measure one variable. I've also put in the initial allocation, in which player A has 2 units of good 1 and 4 units of good 2, and I call this allocation C1. So how do we actually go about solving this model? The first step is to equate the marginal rates of substitution. Once you have done that, which is what I call equation 1 here, you take the physical constraints that we already have from the definition of the model, you solve them for the variables of player B and substitute into equation 1. Then you get what I call equation 2, which depends only on the variables of player A. You then solve equation 2 for x2a, and you get what we call the contract curve. And this, in general, gives you all the Pareto efficient allocations within the box, within the Edgeworth box. And we know that these are Pareto efficient because we derived this function by assuming that the marginal rates of substitution are equal at those points. If the marginal rates of substitution are equal, there's no way that these agents can trade so as to provide for themselves a Pareto improvement. Now, in some exchange economies, the contract curve can contain points for which the marginal rates of substitution don't equate, but they will still be Pareto efficient. That's not the case in the current model, but it will be the case in some other exchange economies that I will solve in future videos. When this happens, it's because the contract curve is going along the border of the box, but that is not the case here. Here I have drawn the contract curve within the Edgeworth box. That's the red line, and it contains all the Pareto efficient points in this model. And you can see clearly that the initial point, C1, is not Pareto efficient. and therefore it cannot be a solution to this problem. I have also included some of the indifference curves at different points along the contract curve, and you can see that they're always tangent at the contract curve. And that's to be expected because that's how we derived the contract curve. Here's the basic intuition behind why they want to trade from the point C1 to somewhere on the contract curve. It's because player A has a larger marginal rate of substitution at C1. Now, the marginal rate of substitution is just the value on the margin of good 1 in terms of good 2. So if player A values good 1 more than does player B, then of course they want to trade. And they want to trade in such a way that player A is buying good 1 in exchange for good 2. And they will only stop trading when their marginal rates of substitution are equal. And that only happens on the contract curve. Here I have drawn the contract curve and the two indifference curves that go through the initial point. I have also drawn the core, which is the blue line. The core is the part of the contract curve that is Pareto superior to the initial allocation C1. Now, they will trade down and to the right because player A will buy good 1 and sell good 2. And eventually they will end up somewhere on the core. We don't know at this point which point in the core will be the solution, but we can tell for sure that they will trade until they reach one of the points in the core. The reason for why they will end up in the core and not somewhere else on the contract curve is because all other points on the contract curve imply that one player is worse off than he is at C1. And of course, no player will agree to trade to a point in which he is worse off. He will only agree to trades if the trade makes him at least as well off as he is without the trade. Now, I should mention that in some models, we cannot find a unique point in the core that is the solution. Sometimes all we can say is that the solution is in the core. Sometimes we can narrow it down to a finite set of points in the core, but we cannot find a unique one. In this particular model that I'm solving in this video, we can find a unique solution within the core. And I will continue to derive that in the next video.